So what we want to work with now is a direct variation. And a direct variation gets lots of names. One name is direct proportion, another is proportional relationship. So if you ever see those words, direct variation, direct proportion, proportional relationship, they all mean the same thing. So let's talk about what they mean. They mean that they are linear. So remember, linear means straight line. Function, and we talked about functions a while back. Remember, a function is any graph as long as it doesn't have points that are straight up and down. So we're not allowed to have a vertical line. So our definition here is that it has to be linear, a straight line, and it has to be a function. So we're not allowed to have a vertical straight up and down line. That is not allowed. Now something else. It must pass through the origin. Remember, the origin is right here where your x-axis and your y-axis meet. So there's your origin. So we have to have a straight line that passes through the origin. And it can go that direction. It can go this direction. It can be super duper steep like this. Okay? It can be not steep at all, almost flat. Okay? But the rule says it has to be linear. Linear, remember, straight line. Has to be a function, so it can't be vertical. It must pass through the origin. One more thing. The slope cannot be 0. Remember, anything with a slope of 0 is horizontal, flat. So we're not allowed to have a horizontal line as a direct variation, and we're not allowed to have a vertical line as a direct variation. The other thing we got to understand is this goofy word, the constant of variation. You see constant of variation, think slope. Okay, the constant of variation is the slope. Now, they talk about a coefficient k. Well, let's talk about that. So far, we have used slope-intercept form, y equals mx plus b. And we know that m is the number attached to x, and that always stood for the slope. Okay? And lots of times our slope was a fraction, like 3/4. Sometimes it was a whole number like 2, and then we said, oh, we got to turn that into a fraction, 2/1, because we always rise and we run. B in slope-intercept form stood for the y-intercept, the place where your line crosses the y-axis. Well, direct variations are often written like this, y equals kx. Well, if we think about this, it's no different than slope-intercept form. K just stands for the slope because it's the coefficient of x. It's the number attached to x. Now, in slope-intercept form, we always said plus b, plus some number. Well, since we know a direct variation passes through the origin, we know the y-intercept is actually 0. So, y equals something times x plus 0. This plus 0 usually isn't written because we don't need it there. When you add 0 to anything, you have what you started with. So, constant of variation is just the slope. It's the number attached to x. So if you get confused in direct variation form, think of y-intercept form, y equals mx plus b, and you should be okay. Let's talk about how this works. Okay? In this one, they give us a table, and they're telling you, they're giving you a hint that it's a direct variation. Right now, that tells you, direct variation, it's got to be a straight line. It's not vertical. It's not horizontal. It has to pass through the origin. They're giving you all kinds of clues. They want us to graph it, and they want us to find the constant of variation. Remember, the constant of variation just means the slope. So I'm going to erase this, the writing I just did. I'm going to bring the graph up higher so we can see it, and we're going to do some graphing. So the first point they gave us, 0, 0. I know that's the origin. That's pretty easy. The next one they gave us is 3, 4. Remember, the x value tells you how far to walk. The y value tells you how far to climb. The next one they gave us is 6, 8. I'm up there. The next one they give us is 9, 12. Well, that's going to be way off the graph. I don't have room on my board right now. But I do know there's a pattern. And I saw the pattern to get from this dot to this dot was to go up 4, rise 4, and to the right 3, run 3. So I can reverse that pattern and go down 4, 1, 2, 3, 4, and left 3, 1, 2, 3. And I could continue that again. Again, I'd run off the board. But that gives me a nice straight line. And I should have used my straight line tool. We should put arrows at both ends. Remember, every point on that line is a solution. A line is made up of millions and millions of points. All right, so we did the first thing. We graphed it. The second thing, they want us to find the constant of variation. K stands for constant of variation. Remember, constant of variation just means the slope. And to find the slope, we do what we've been doing for weeks. Rise and run. I'm going to rise 1, 2, 3, 4. I'm going to run 1, 2, 3. So the slope is 4/3, or the constant of variation is 4/3. Not too bad. How can we use this? Well, they want us to write an equation. Now they give us a big clue here. They say it's a direct variation. We know a direct variation must pass through the origin, and the origin is 0, 0. A direct variation. Remember, a direct variation looks like this. Y equals kx. If that's confusing, think slope-intercept form. Y equals mx plus b. M stands for the slope. B stands for the y-intercept. So I got y equals something times x plus something. This is the slope. This is the y-intercept. They told us it's a direct variation. A direct variation must pass through the origin, and the origin means that the y-intercept has to be 0. So we got that part. Next, we need to find the slope. One way to find the slope is to use our formula y1 minus y2 over x1 minus x2. Some people write it as y2 minus y1 over x2 minus x1. It doesn't matter which of those formulas you use, you're going to get the exact same answer. So let's try it. 3, I'm going to say, is my x sub 1, and negative 5 is my y sub 1. This would be my x sub 2, and this would be my y sub 2. If I substitute those in either formula, I'm going to get the same answer. For me, my y sub 1 is negative 5, minus my y sub 2 is 0. My x sub 1 is 3, minus my x sub 2 is also 0. On top, negative 5 minus 0 is negative 5. On the bottom, 3 minus 0 is 3. So my slope is negative 5/3. This could be my answer if I want it to be. It says write an equation. That's an equation that would work. Or I could use this equation right here. Y equals, remember K stands for your constant of variation or your slope, and I know my slope is negative 5/3. X, and I don't need to write plus 0. So it's a direct variation. I can get by with this right here. Okay? Now maybe you noticed in this problem and the last problem something that would save you a little time. Okay? And there was a shortcut. In a direct variation, there's a shortcut for finding the slope. And you'll see it if you take a look here. Look at this point, 3, 4. Okay? The y value is 4. And y always means climbing, how far you climb. Okay? X value is how far you walk, the y value is how far you climb. So I could put my y value on top and my x value on the bottom because I'm going to climb 4 and walk 3. Hey, the slope was also 4/3. That's what I got here. And you might say, well, that worked for that one. Would it work for every point? It will work for every point on this line except for the origin. Okay? For example, 6, 8 here. I could put my y value on top, which is 8. My x value on the bottom, which is 6. If I simplify that by dividing by 2, I get 4/3. My slope was 4/3. It works for this value, 9, 12. Put the y value on top, 12. Put the x value on the bottom, 9. Divide everything by 3. And again, we get 4/3. So that's just a shortcut. That shortcut only works for direct variations. It's just a shortcut way to find your slope. It would have worked here too. I wouldn't have needed this 0, 0. I could have just looked at this. My y value is -5, and the y value goes on top. My x value is 3, that goes on the bottom. Hey, that was my constant of variation, or my slope. And that's what I used in my equation. So just another shortcut way for you. So how can we use it? We just practiced one like this. If you want to try the shortcut, y equals kx. Y equals, remember k stands for your slope. And we said the shortcut way to find slope in a direct variation is to put your y value on top and your x value on the bottom. So my slope is 5/3 x. Done. Goes pretty quickly. Okay, here they want us to graph a few points. So let's graph -1, -3. They want us to graph 0, 0. They want us to graph 1, 3. They want us to graph 2, 6. Okay, I see a pattern here. That's good. Let's see. They also want us to find the constant of variation, find the slope. Remember the shortcut way we said? Take a y value, put it on the top of your fraction, the x value on the bottom. I'm going to use this one, 3/1. Hey, the slope is 3, or 3/1. Let's see if it works for this one. The slope would be 6/2. That's 3. Let's see if it works for this one. Slope would be -3/-1. That's +3. We get the same slope every time. The only time you can't do that, you can't use that shortcut with the origin. That's not going to do anything for you. Okay? Hopefully you understand a little bit about direct proportions today. Remember, direct proportions mean the same thing as direct variation, proportional relationship, direct proportion. It all means the same thing. You might think, well, how did it get its name? Well, it's directly, the y value is directly proportional to the x value. All that means is to get from the x value to the y value, you only had to do one step. In this case, you had to take it times 4/3. So for example, the x value of 3 times 4/3 gets you 12/3, which is 4. So that's how it gets the name direct proportion. It's the y value is directly proportional to the x value. Good luck!